Okay, just imagine this for a second. What if you could get the absolute legends, the creators of modern AI, all in one room to just hash it out, to debate the future of this thing they built? Well, that's exactly what happened. And for us, we get to be a fly on the wall for that whole conversation.
And look, we're not just talking about some smart academics here. These are six pioneers who just won the world's most prestigious engineering prize. Think about it. From the actual silicon chips in our computers to the algorithms that are basically rewiring our society, their work is, and I mean this literally, building the world of tomorrow. So let's break down this incredible conversation, shall we? First, we're going to go back in time and look at those aha moments that sparked this whole revolution in the first place. Then we'll jump right into the big debate everyone's having. Is this whole AI boom a bubble? And finally, we're going to get to the really juicy stuff, their predictions on that one massive question. How far away are we really from human-level intelligence?
All right, first things first. Let's meet the minds behind all this.
So you've got the three godfathers of AI, right? Geoffrey Hinton, Yann LeCun, and Yoshua Bengio. These guys laid down the theoretical blueprints. Then you have the architects of the engine itself, Jensen Huang and Bill Daly, the ones who built the actual hardware that makes it all run. And you can't have an engine without fuel. And that's where Fei-Fei Li comes in. She's the one who gave the machines the massive amounts of data they needed to actually learn anything.
You know, every revolution has its origin story, right? A spark. For these pioneers, it wasn't just one big bang. It was a whole series of personal aha moments. These were breakthroughs that, and this is the crazy part, often happened decades before the rest of the world was even ready to listen.
And this timeline, man, it tells such a fascinating story. You see, it starts way, way back in 1984 with Geoffrey Hinton's first little experiments. But get this, the idea just kind of sat there on a shelf for years. It wasn't until the late 90s that Bill Daly started chipping away at a huge hardware problem. Then, fast forward to 2007, and Fei-Fei Li comes along with the giant data set that these models were starving for, and the final piece of the puzzle, it literally clicked into place over breakfast in 2010, connecting the super powerful hardware with these new deep learning ideas. Every single one of those steps was absolutely crucial.
Just listen to what Hinton says here. He's basically saying that the core idea behind all these large language models we have today, using this technique called backpropagation, which is really just a fancy way of saying learning from your mistakes, to predict the next word in a sentence, he proved it could work all the way back in 1984. Seriously, think about that for a second. So why did it take 40 years to get here? The answer is actually pretty simple, but it was a massive hurdle. They just didn't have enough data or enough raw computing power. And that's the perfect lead-in to Fei-Fei Li's big aha moment. She looked around and realized that all these brilliant researchers were trying every single algorithm you could imagine, but their machines were just starving. They were information deprived. I mean, we humans learn from this constant flood of sensory information, right? So she spearheaded the creation of ImageNet, this absolutely gigantic dataset with 15 million images, all labeled by hand. It was the fuel that this AI engine was so desperately crying out for.
Okay, so at the same time, over on the hardware side, Bill Daly was hitting his head against this problem called the memory wall. It's a huge bottleneck. The best way to think about it is like this. Imagine you have the world's fastest chef, just a blur of motion, but he's getting his ingredients delivered one single carrot at a time on a super slow cart. That's the problem he was facing. So his work on GPUs was basically like ripping out the cart and building a massive high-speed conveyor belt that just dumps all the ingredients he needs right in front of him all at once. And that right there is exactly what deep learning needs.
And this is where Jensen Huang from NVIDIA comes in and just ties it all together. He had this amazing insight. He realized that the very same strategy they used for scaling up hardware, just making bigger and more powerful chips, could work for software too. That one idea completely transformed NVIDIA's entire game plan. It's what allowed them to go from building a single GPU to building these massive AI factories, the giant data centers that are the powerhouse behind all the AI we use today.
Okay, so that catches us up to right now. We've got literally trillions of dollars pouring into this field. And the question on everyone's mind is this a real, sustainable revolution? Or are we just living inside a giant bubble that's about to pop? And you know what? The pioneers themselves, they don't agree. They're pretty much split. And the argument isn't really about whether AI is useful. Everyone agrees it is. The debate is about what kind of AI we're actually building. So on one side, you've got the hardware guys, Jensen Huang and Bill Daly. They see a total revolution in what's being used. They're like, look, every single GPU we can make is being used, and we've barely even scratched the surface. But then on the other side, you have the scientists, like Jan LeCun, and he's pumping the brakes of it, saying, yeah, this is great, but there's a bubble of expectation. A bubble in the idea that our current method, just making bigger and bigger language models, is the one true path to human-level intelligence. It's really a classic debate, the engineers versus the scientists.
And this number right here, this perfectly sums up the argument for not a bubble. Just 1%. Let that sink in. If Bill Daly is right, and we're only at 1% of what AI can ultimately do, well, the potential for growth is just, it's almost impossible to wrap your head around. It feels like we're standing at the very, very bottom of a massive exponential curve.
So all of this naturally leads us to the big one, the holy grail, the ultimate, almost philosophical question. How close are we to creating artificial general intelligence, or AGI? You know, a machine that can actually think, reason, and create just like a human can.
And wow, their predictions on this are all over the map. It's fascinating. You've got the bold predictor, Geoffrey Hinton, who puts a number on it. He says definitely within 20 years. Then you've got the pragmatists, Jensen Huang and Bill Daly, who are basically saying, hey, that's the wrong question to even ask. For them, the goal is to help humans, not replace them. Others, like Jan LeCun and Fei-Fei Li, they see it as a much slower, more gradual thing. But then, Yoshua Bengio throws a total wildcard into the mix. He asks what happens when AI starts doing its own research. That, he thinks, could just completely rewrite the timeline.
So, after all of that debate, all that disagreement, what's the big takeaway? Well, believe it or not, a really clear consensus actually did emerge about what the path forward really looks like.
Yeah, if there's one thing they all came together on, it's this. There is no big red button. There is no AGI light switch that somebody's going to flip one day. The whole sci-fi idea of a single moment where the AI suddenly wakes up, that's just not how it's going to happen. The reality is going to be a slow, continuous, rolling process of discovery and application. It's an evolution, not a single dramatic event.
And that really leaves us with one final, crucial thought. If the future of AI isn't some destination we're racing towards, but a path that we are actively building, then maybe the most important question isn't when we'll get there. Maybe the real question is, how will we, all of us, scientists, engineers, everyday people, how will we continue to shape it?